Hello everyone, in this video I'm going to show you how to connect the 4F board. This board has 4 faders, each fader has an LED, and on the connection side we have a header connector for the faders and another connector for the LEDs. Okay, so because the Teensy runs at 3.3 volts, we need to power the module with the 3.3 buzz, and I'm going to power the module like this, paying attention to the positive and the negative. And just for you to see the LEDs, I'm going to connect all of them to the 3.3 volts, and if I connect them here, they will all light up. Okay? But we are going to control them with our program. Okay, so I'm going to connect the LEDs to the pins 3, 4, 5 and 6. These pins have PWM. Okay, let's just write a simple program to drive the LEDs. So first variable, let's call it LED1 pin on 3. Then LED2, LED3, LED4, and each one of the LEDs has a dedicated pin. Then on the setup function, let's tell to our microcontroller that each one of these pins is an output. And on the loop, let's just make a blink simple program for the LEDs. With a delay. Oops. Okay, digital right, LED to high, and then digital right, LED low. Upload it, and as you can see, the LEDs are blinking. Now let's read the faders. They are analog, so let's connect them to the analog pins on the Teensy, and I'm connecting them to the 14, 15, 16 and 17. Oh, okay. Hopefully you can see it. 14, 15, 16 and 17. And on the Teensy, this is the A0, A1, A2 and A3. Okay, I'm just deleting everything. This can stay, and add more variables to the faders. I'm calling here byte, variable type of byte, to hold A1, A0, A1, A2 and A3. On the setup, I don't need to instantiate pin modes as input because they are analog, but I need to start a serial port and let's also create more variables to handle the potentiometer's value. Okay. Fader 1 val, fader 2 val, fader 3 and fader 4 val. And fader 1 val is equal to analog read fader 1 pin. Let's do the same for all the faders. And now let's print these values to the console. This serial print with a dash T will add a tab, will add a space between each value. Let's upload it and see what we got. Okay, our faders. Now, if I want to light the LED according to the readings of my fader, so the fader have this range of 0 to 1023, but the PWM has a range from 0 to 255. So we need to scale down this value to the PWM range. And we can do this in two ways. Let's start with the first LED. And because we are using PWM, we need to use analog write. And the analog write will receive a value from 0 to 255. And because this value gives a range of 0 to 1023, as you can see here, we need to scale down this value. So let's first, there is this very handy function called map that receives a value. We need to tell the range of the input, which is 0 to 1023, and then we need to tell the target, the range of the target that we need. Okay, of course it's giving an error because I need to put this value here on the analog write. Now, as you can see, I'm moving this fader and it's turning on, it's fading out this LED. So let's just invert the connection. And now we are passing the value from the fader, scaling it down, and passing this value to the PWM on the pin. And we can do everything for all the other pins. Okay, let's just copy and paste, change our variables here, and do the same here. 2, 3, and 4. 2, 3, and 4. Okay, let me just turn off this light. Now, just to let you know that this can be simplified, instead of doing this map function, because this is a linear scale down, we don't need to do this. We can just divide this value by 4. 1023 divided by 4 will give us 255. Okay, as you can see on the console, we have a range of 255, and this value is passing directly to the analog write function. If these concepts are new to you, and if you have any question, just leave your question in the comments below. So I hope you like this video. See you on the next one.